Hello, in this video I'll be demonstrating three different reflectance models implemented using WebGL and GLSL shaders, just using WebGL for simplicity, so we can run it in the browser. And also means we can make a nice little web app showing these. Anyways, we'll be comparing the Phong model, the Cook Torrance model, and a non-photorealistic Toon shader. As you can see on screen, we have three spheres rotating side by side, each implementing one of these models. This demo is built using Three.js as a WebGL framework with custom GLSL, vertex, and fragment shaders implementing each reflectance model. Each sphere receives light from a main directional light source and a blue tinted fill light. You can see this. You can see that light ray as the coming out from the Cook Torrance sphere in the middle. That's our light source. You can see the interactive controls on the right as well that allow us to adjust various parameters. Here I'm changing the shininess on the Phong model, for example, and the specular, as you can see. So let's get stuck into it. So starting with the Phong model, this model combines three components: ambient reflection, providing basic environmental lighting; diffuse reflection, following Lambert's cosine law; and specular reflection, creating the characteristic highlights. As we can see here, how to adjust that. The key parameters we can adjust are shininess, which controls the size and intensity of specular highlights, and the specular coefficient, determining the overall strength of the specular component. As you can see, when I adjust these values, higher shininess creates smaller, sharper highlights, while lower values create broader reflections. So the next model, the Cook Torrance model. So the middle sphere here implements the Cook Torrance model, which is a more physically based approach to reflectance. This model uses microfacet theory, treating surfaces as collections of tiny mirrors. It consists of three main terms: the distribution term, which models how microfacets are oriented; the geometry term accounts for self-shadowing of microfacets; and the Fresnel term describes how reflectivity changes with viewing angle. The key parameters here are roughness, as you can see here, which I'm changing. You can see I guess it'd also be called a specular, changing as I change it, and metalness. So roughness controls the microscopic surface variation. Metalness determines how metallic the material appears. They're super high, they're super low. I guess we can move on to our Toon shader now. So the right sphere here demonstrates a non-photorealistic Toon shader. So unlike the previous physically based models, the shader deliberately creates like a stylized look. Really not photorealistic. Looks like it's out of a video game or something. It does this by quantizing light intensity into distinct bands, adding edge detection based on the viewing angle, and sharp transitions between light levels. So this creates the characteristic cel-shaded look popular in animated films and games. You can notice how the lighting transitions are sharp and clearly defined. Our parameters here to change is basically just the lighting source, as you can see there, which changes where those like quantized bands appear. Most prominent really just when I change the y, the y angle of the light. This light x angle I'm just realizing isn't quite there, but anyways. So just to tell you about how these are implemented, did it using GLSL shaders with vertex shaders handling position and normal calculations, fragment shaders implementing the lighting equations, and uniform variables for adjustable parameters. So each model receives the same lighting information but processes it differently according to its specific equation or algorithm. So the rotating spheres help demonstrate how each model handles lighting changes and surface orientations. And I included a display of that lighting model with the ray, as you can see with the Cook Torrance model there in the middle. So these three models demonstrate different approaches to surface reflectance: the Phong model providing a classic computationally efficient solution, Cook Torrance offering a more kind of physically accurate solution, and the Toon shader just for a bit of fun. So each has its own use cases in computer graphics, balancing between physical accuracy, computational cost, and just how artistic it's supposed to be. Thank you for watching. I'm Tim Farrelly, student number 19335376.